In this video, I'll show you two examples on how to write an equation for a circle from a diagram. Question 1 reads, write the equation of the circle found below, taking the axes as shown. Use your equation to find A and B. Let's take a closer look at this diagram. What we have here is a circle cut out from a rectangle, and we need to find A and B. The first of these two letters that I will find is A. And I'll do that by extending this radius down to this point of the circle and using 1.98 as this length and 2.50 as this length. I can find out the length of this side. Then using that side, I can find out A. Let's go ahead and do that. I'll redraw the right triangle where this length is 1.98 and this length is what we're looking for, and the hypotenuse is 2.50. Using Pythagorean's theorem, a squared plus b squared is equal to c squared, I'll substitute 1.98 as my a, and this will serve as my b. 2.5 will be my c. Rearranging for b squared, 2.50 to the power of 2 minus 198 to the power of 2. And then whatever I find on the right side, I'll square root, and that will serve as my b value. 2.5 to the power of 2 minus 1.98 to the power of 2 gives me 2.33. That's rounded using the correct number of significant figures. Also, don't forget to square root this number. 2.33 square rooted gives us approximately 1.526. 1.53. So we found the length from here to here. We know the length from here to here. To find A, we will subtract 8.75 from 1.53, the number we just found, minus 1.22. Our calculator gives us the answer 6. This tells us that from here to here, the length is 6.00 centimeters. Now to find the length of B, what we need to do is extend this radius, and if we extend it, double its length, this gives us the diameter of the circle. Therefore, the diameter of the circle is 5, and what we've produced is a right triangle with the hypotenuse of 5. With this right triangle, we can find out the length from here to here. And the way we do that is add up the length from here to here. So using our calculator, we have 1.22 plus 1.53. That gives us 2.75. 2.75. The hypotenuse we know is 5. And we'll use the Pythagorean theorem to find out this length. So I'll set it up for you. We end up with A is equal to the difference of these two numbers. Using our calculator, the square root of 5 to the power of 2 minus 2.75 to the power of 2 gives us 4.17. Now what we do is subtract 4.17 from 6.25. And I'll do that right here with the space that I have left. 6.25 minus 4.17 is equal to 2.07. And that's in centimeters. Let's move on to question 2. In question 2, we're asked to write an equation for the circle shown below and find the dimensions A and B produced by the circular cutting tool. This one is slightly more complicated than the previous question. We'll start this question by creating an equation that represents this circle, but be aware that the axes, the y-axis and the x-axis, are reversed in this question. We can also assume that this circle is at the origin, and notice that the point, the center of the circle, is at 0. If a circle is centered at the origin, it gets the equation x squared plus y squared is equal to r squared. And our radius is 1.500, while the left side remains the way it is. Let's find out what the right side is equal to. To the power of 2, we end up with 2.33 250, just to keep the right amount of significant figures. This equation represents the circle. Now we need to find A and B. To find out what our A is, what we can do is subtract 4.155, which is the length from the center of the circle all the way to the edge of the box, from 3.148. And what that will give us is a point right here. This point is significant, and I'll explain why in a second. So 4.155 minus 3.148 gives us, using our calculator, is 1.007. 1.007. Therefore, any point along this x will serve as our y. How do we find out the corresponding y value for, let's say, this or even this? How do we do that? Well, we can substitute this back into the equation that we just created. 1.007 squared plus y squared is equal to 2.250. And let's solve for y. Let's find out what this is equal to. Square that, and then subtract it from 2.250. Think of it this way. We're pulling it over to the other side to solve for y. So this number, subtracted from this number, gives us 1.235. 1.23, and I'll make this into a 6 because of that 9, is equal to y squared. Square root both sides, we end up with, so squaring this number, we end up with 1.112. 1.112. Of course, this can be plus minus y. We're going to choose the positive version because going to the left is plus y. Anything this way is negative y. So this point right here has the coordinates 1.007 and 1.112. To find out our A, all I have to do is subtract that from 3.715. So A is equal to 3.715 minus 1.112. Using our calculator, 715 minus 1.112 gives us 2.603. We just found our A. Now to find our B, we need to do something similar. In fact, the first step to finding out B is to subtract 4.146, the dimension from this edge to this edge, with 3.715, which is the distance from here to here. And that will give us this part. That will give us that, which we can then use to find our x. So as mentioned, I'll subtract 4.146 from 3.715 using our calculator. 4.146 minus 3.715 gives me 0.431. I just found the length of this part. Therefore, when y is equal to 0.431, let's pretend that this is 0.431, or you can even say negative 0.431. If you plug this into the equation that we built, and let's do that, x squared plus 0.431, whether you make it negative, positive, doesn't matter because you're squaring it, is equal to 2.250. If you do this successfully, you should end up with the following number: 1.43, going up to 4 significant figures, 1.437. This number tells me the point right here. In fact, we have the coordinates 1.437 and 0.431. Now all I have to do is subtract 4.155 from the x value that we just found, and that will give us b. Let's go ahead and do that. b is equal to 4.155 minus 1.437, using our calculator one last time, gives us 2.718. 2.718 centimeters. And that represents the distance from here to here. And there you have it. 2 examples on how to write an equation for a circle from a diagram.